Hi, this is Mr. Libby with week 28's stoichiometry do the U assignment for day 1 of the week. You have a grid to follow on page 8 of your notebook. We're going to go over that. The next slide, this is where I'm going to put the video. This is the do the U grid that I'm talking about. So over here it says the A, B, and C and D are chemical formulas, and the little a, the little b, the little c, and little d are the coefficients. So that's what those are there. You'll be given something in the problem. It'll probably be grams, and this assignment it is grams. So you'll either be given grams or moles. This one, you'll be given grams. So when you're given grams, you're going to take your mass divided by your formula mass and come down. All right. One real quick, brief thing I want to mention first is, let me put this first, is that units. We will not talk a lot about units in the do the U grid. The units are there. They're all here in the on the side here. So everything in this column right here is grams. Everything in this column is grams per mole, and everything in this column is moles. But the way the do the U grid is set up is that you are able to get the moles just by following the divide down, multiply up. So the way the grid is set up, when you divide down, you take mass divided by formula mass. You take mass divided by the formula mass, and you get the moles, which is what this says. So just the way the grid is set up, it'll work out. Your units will work out. And then this one says moles times formula mass is the mass, and this one is moles down here times formula mass is the mass, and that says right there. Moles times formula mass is the mass, and so that's the way it works out. All right, let's look at this part. You have 4 problems to do for the only assignment we're doing on day 1. I will do one of them, so you have 3 problems to do. So right here, there's a balanced reaction for you. That's the first important part, is you need a balanced reaction because the mole ratios need the coefficients for the balanced reaction. The formula masses can't be the hard part. I mean, that's just adding things up on the periodic table. When you divide down, you get 25 divided by 107.87. You're going to get something that looks like that, 0.23. That is moles of A. Now the mole ratio part is the hard part. So how do you get the other moles? Well, the mole ratio part says you take the little coefficient B, which is right there, divided by A times moles of A. And this is going to be C divided by A times moles of A, D divided by an E, and F, and it keeps going. So now here we go. This is going to be our B. So 4 divided by 3 times moles of A, that's what I did right here. 4 divided by 3 times moles of A, and that's what I got. And this one is going to be 3 divided by 3 times moles of A, which you can probably do in your head. This is 2 divided by 2 divided by 3 times moles of A, which is right there. And this is 1 divided by 3 times moles of A, right there. So that's the hard part, getting this mole ratio part and then multiplying that. And then the easy part is you just multiply up. And when you multiply up, you get that. How do you know if you're right? Well, the law of conservation of mass says you cannot create mass nor destroy mass. That means all the mass has to be there. Mass is this column right here. This row right here. Mass is that one. So when you go to the next one, next slide, does it satisfy the law of conservation of mass? Well, everything on the left side of the arrow, when you add it up, has to equal everything on the right side of the arrow when you add it up. So if you add them up, you get 44.47, and if you add these up, you get 44.47. If that happens, you know you're right. You can't mess up the grid and get the law of conservation of mass to work. So you know you're right. The other questions, rocket fuel, you make nitrogen and water as byproducts. Those are both useful in space. That's pretty cool. This is a industrial process to make manganese, which is a high-strength, lightweight metal. And then camels, why don't camels need as much water as other things seem to do? Is because they have this fat in their hump. When they burn it, they make water. So they use the byproduct of water that they had from their hump fat to survive. All right, that's it. We're going to call it a day here, and we'll start again with a self-grading sheet on Tuesday, Thursday.